Hello everyone. Am I live? Am I audible? Write in the chat box. So I'll just check. Okay, so some people are just writing yes. Oh, that's good. That's good. Okay, so this is Alok here, your favorite educator, and I'm here to discuss some IMO problem, at least one. And time is less, but let me try to make it more interesting. Before we do that, let me just do some kind of information thing. So Unacademy Champs 2.0 begins. You can check that your race towards JEE 2022 top ranks. Jan 2 you have got some 2 p.m. 3 hours, and you can secure some top ranks and get a lot of exciting prizes. Apart from that, of course, you gain your knowledge also. So that's the main thing for me. Then ITG Plus offered is like buy 6 and plus 1 month extension, and buy 18 months and plus 2 months. So all the more reason to get a new subscription for those who you know or you can recommend people. Then we have got batches starting like Champs batch and then Edge batch for JEE Mains Advanced. Do check them out. Then only mock test series starting January 2 every Sunday 2 to 5 p.m. and much more. And Ask a Doubt feature. So that's all for the promotions for now. And let me now just quickly tell about myself, the people who might not know. So a quick look about me, that this you can read them later. So this I'm a beater from IIT Kanpur, and I was also an IMO medalist, and I'm writing many problems in international magazines also. Other things you can just Google or you can check. I'll quickly go over it so that we can do some useful problems. And so other that you can go to my AHA lectures. You can also avail discount by applying the code AlokSirLive. That's my code. Or you can tell people, and my classes are going on Unacademy Plus, both IIT classes and Olympiad classes. You just check them out. And now we come to the main topic of today's. So it's going to be a short session. So I've just chosen an IMO problem. It is inequality problem. Last year also it was too tough. It is not of last year. It is long back, but it's a good problem. And the point is that it does not have symmetric equality case, because that is easy to find out. So let's look at the problem and let's solve it. So determine the smallest number m such that the inequality AB times a squared minus b squared plus bc times b squared minus c squared plus ca times c squared minus a squared modulus less than equal to m times a squared plus b squared plus c squared whole squared holds for all real numbers. You want it to hold for all real numbers a, b, and c, and so you have to find out the things such that it holds for all real numbers. So obviously these kind of things, an answer is not so much that you can guess easily. You really have to solve them, unlike some other problems where you can sometimes guess. So see like this, that if I first of all I will just write this as inside expression as ab a squared minus b squared plus bc b squared minus c squared plus cs c squared minus a squared. You can factor it in many ways. I will just tell two of the ways. So one way would be that I will write p of t as, so write just a in place, t in place of a. So this is tb, and then t squared minus b squared plus bc b squared minus c squared, and plus c times t and c squared minus t squared. So what I have done is that I have written t in place of a. That just lets me feel that it is a variable, right? So this kind of device is normally used just to distinguish this one. Now it is a polynomial. So consider this polynomial in t. It is polynomial in t. If you put t equal to a, then you will find that p of a is 0. You can check that easily, that p of no, you can put t equal to b, in fact, not a, because already a we have taken to polynomial. So if you put t equal to b, then p of b equals 0, means value of p at b is 0. Similarly, at t equal to c, p of c equal to 0. If you want, you can just, I can show you the check that if you write p of b, then p of b is just put t equal to b. So this is b squared, and b squared minus b squared, plus this is bc, b squared minus c squared, and you are writing t in place of b, so cb, and this is c squared minus b squared. So you are just substituting t with b. So these terms anyway cancelled, and here they are opposite of each other. It is b squared minus c squared, this is c squared minus b squared, so they two give you 0. So t at b is 0. So value of p at b is 0. Similarly, value of p at c also is 0. That of course is no-brainer, you can check. The interesting part is that value of p at negative b, negative c. Value of p at negative b, negative c. You will find this also is 0. We can check this, like we can check the, you can put the values. So we can write minus of b plus c times b, and we can write b plus c squared minus b squared plus bc, b squared minus c squared plus c times negative of b, negative of c, and c squared minus b plus c whole squared. So we can put that, and we can quickly check that this will turn out to be 0. You could also have guessed it like this, that if I write t more closely, I'll write that this is t cubed. See, it is t cubed b minus c. So it is like b minus c times t cubed. So coefficient of t cubed, leading coefficient t cubed. So b minus c times t cubed. Then you will get t squared terms, t squared, other terms, and then you would get coefficient of t. T squared term will be 0 because you see bc plus c, so t squared, and then you will get coefficient of t. I am not concerned about, and the constant term, that is of course bc times b square minus c square, is a constant term because others all have got factor of t, right? So this is your constant term. Now this is good enough. If it is constant term like this, you can check that b plus c will of course come. That you can check also. No, you can't do Vieta jumping here. Vieta jumping has no role here. In fact, Vieta jumping has no role here. This is just, we are just factoring. We are simply factoring the polynomial, right? So for that, we should not abuse the term Vieta jumping, right? So we are simply factoring equations. So we factored. Now once we factor, then we get that this polynomial. So we are getting p of t is t minus b, polynomial in t minus b, t minus c, and leading coefficient is b minus c. So you can write this is b minus c here, and one more term was t plus b plus c, this one, right? Beta jumping is of course very beautiful, but it has got its own legitimate uses. This may not be the correct place. Okay, now p of t is this one. P of t is this much, and now if you put p of a, you put a here, then we get p of a is b minus c, a minus b, a minus c, a plus b plus c. If you want to write cyclic order, you can write negative of a minus b. That will be more pleasing. A minus b, b minus c, c minus a, and times a plus b plus c. This is one way of factoring this expression, which is at the heart of it. That means first I must play with this expression. First I must know what it means, and then I will come to the second part, right? That inequality, that what is there. So we have agreed this. Let me write on the next page, this one. So it is ab times a squared minus b squared plus bc times b squared minus c squared plus ca times, it's a tough inequality. This is negative of a minus b, b minus c, c minus a, and times a plus b plus c. You can just note that this also written as sigma a cubed times b minus c. This is this factor, negative of a minus b. In itself it is important because many times questions have been asked based on this. You will find that in sigma a to the power n b minus c, this will always make its appearance. This will always make its appearance because left hand side will vanish when two of the numbers are equal, like a equals b or b equals c or c equals a. So those things will keep happening. So in fact a and b minus c there, and in one of my videos that I made, you will find on those lectures I have extensively discussed these concepts, and many contests like AMC or AME or other contests keep making use of that, right? So this, okay, I'll try to increase the pen size. Senpai or somebody, I'll just, so this is this all common, and then other things of course follow, right? So this is for separate lecture that we have already done. Coming back to this one, I got now, and then I will now inform the ordering. So let me write A less than equal to B less than equal to C. Do the ordering. This kind of ordering is important. So our expression was modulus of A minus B, B minus C, C minus A. We already factored A plus B plus C. I want some M such that this happens. A squared, B squared, C squared, whole squared. This happens. This I want. That this should happen. So if I do this ordering, then that takes care of modulus. And so I can write this as B minus A times C minus B and times C minus A. And A plus B plus C is anyway positive. So A plus B plus C, they are given to be positive real numbers or all real numbers. Just check if it is all real numbers, and then I will still do mod. It is all real numbers, right? So I can still be okay with mod. So I'll write mod only, because this I cannot get rid of, right? So I can get it off. I'll just write this is mod or total mod, this one. And this is less than equal to M times A squared plus B squared plus C squared whole squared. M times A squared plus, I hope this pen size is somewhat increased, A whole squared. Okay, now let's deal with it. Now let's deal with it, that how we can do these things. So B minus A, I can have one equality this way, that B minus A time, because this is positive now B minus A is positive, right? A, B, C are real numbers, but because we have done the ordering, so B minus A and C minus B are non-negative to be precise. So this is less than equal to B minus A, AMGM inequality, B minus A plus C minus B whole square over 4. Means I am using this version xy less than equal to x plus y whole square by 4. This also is valid even if x, y real numbers, but I am taking here positive numbers or non-negative. So this is all right, this one. So now this will come that B minus A times C minus B. You can just notice that how really beautiful things goes into making an IMO problem. So first victory is this one, that we got this small thing. This we know. Every high school students know this one, B minus A, C minus B. And this is again C minus A, so I can multiply that. So I'll get B minus A times C minus B times C minus A less than equal to C minus A cubed divided by 4. So this we have taken care of somehow. A plus B plus C remains, right? So don't worry, we'll have a lot of things to say about it. So let us go to the next one. So I get B minus A times, so this was A, B and C, C minus B and C minus A, C minus A. So C minus A times mod A plus B plus C, or you can write mod throughout even if there is nothing problem. So this is mod A plus B plus C. This is less than equal to C minus A squared. Let me check last what we wrote, C minus A cubed by 4, right? So we wrote 1 by 4 modulus of C minus A cubed and A plus B plus C modulus, this one, C minus A cubed. Let me deal with this C minus A cubed. It's not symmetric. I don't like that. So what I do, that I can write this as, first I will write this as 1 by 4 equal to 1 by 4 and a square root of C minus A to the 6 and A plus B plus C whole squared. This helps me. Why this helps me? Because I can write this as modulus. Modulus is gone now. Modulus is gone. I'm just writing mod of AB, mod of something B, mod of B is root of B square, right? Or let me use a different symbol. So I'm writing modulus of alpha, something modulus of alpha is root of alpha squared. So this squared has come up, and some more benefit we will see soon, that why it will be beneficial. Now let me relate C minus, this is not a good thing, because if you remember, the right hand side is very symmetric, right? It's in A, B and C. So M times a squared plus b squared plus c squared whole squared. So I have to relate this thing, I have to relate this whole thing in some way to this mysterious a squared plus b squared plus squared, this thing. I mean, this has to come somewhere, right? This has to come somewhere. So let's check how this can come. This obviously is not correct because c minus a, or not the suitable thing, because c minus a has still the problem, right? Yes, this has come in an IMO, right? This has been asked in IMO. It was not proposed, but it was really asked. Okay, so you wanted the smallest constant m. Now what will happen is this, that c minus, there is one more thing that I can do here. So I am writing this way, that c minus a, so I will use something called RMS AM. RMS AM I'm using. So I'll write c minus b plus b minus a over 2 whole squared. This one, I hope you are following. C minus b squared plus b minus a squared over 2 means I'm writing this in other form, x squared plus y squared by 2 greater than or equal to x plus y by 2 whole squared. This I'm writing. Things are all positive. So I can write c minus a, all positive means c minus a and b minus a. So c minus a squared over 4 less than equal to c minus b squared plus b minus a squared over 2. So I can write that c minus a squared less than equal to 2 times c minus b squared plus b minus c minus b squared plus b minus a squared. This is b minus a. So this is b minus a squared. B minus a squared. So I can write this is b minus a squared. Just add c minus a squared to both sides. So if we add 2 times, so we add 2c minus a squared plus c minus a squared. This is less than equal to, this is 2 plus 1 3. So you'll get 3 times c minus a squared plus c minus b squared plus b minus a squared. Notice this thing. Now you have got all things. This is 2 still. Now you have got all things symmetric. C minus a, c minus b, b minus a. And this is good. So I can write 3 times c minus a whole square less than equal to 2 times c minus a squared plus c minus b squared plus b minus a squared. This we are writing. C minus b, b minus a squared. Let me piece together this one now. This is 1. This is, let me name it 1. And this, let me name is 2. And I will derive from it another consequence. So this was expression. Let's call it p. Let's call it p. This is p. So in anybody having any difficulty in following, they can quickly ask some questions. So we got p. We got p less than equal to 1/4 of and square root of, and the square root of, you have got c minus a whole to the 6 and times a plus b plus c whole squared. Take care of the coefficients. A plus b plus c whole squared. This is one that we are writing. Okay, and then we also got c minus a squared, c minus a squared, c minus a squared. Remember, a less than equal to b less than equal to c, they were real numbers. So I got c minus a squared less than equal to 2/3 of some symmetric thing, that is b minus a squared from b, then c minus b squared and plus c minus a squared. This one. So I can combine them and I can write p less than equal to 1/4 of and c minus a whole to the 6. So c minus a squared is this one. So this is less than equal to 2/3 of this big thing, b minus c squared, b minus a squared, 2/3 of. So this is 2/3 of this big thing, b minus a squared plus c minus b squared plus c minus a squared, and this whole squared, because that is your, this is whole cubed rather, because this c minus a squared is there. So this is this one, and a plus b plus c whole squared. Just take a good look at it. This is essential to just check. So I write now again, this equals 1/4 of, and this is, So this is 8 over 27. So 8 over 27, you have got b minus a squared plus c minus b squared plus c minus a squared. 3 copies of that. So cube, this is cubed, and times a plus b plus c whole squared. Is that clear? Some viewer can tell that yes, that's all right, that's clear, that you understand all of them. 1/4 of 4th root of this one. So 8 over 27. Okay, it's all right. B minus a squared, c squared cubed. Correct? Because we can write this inside, and so this we are good that we have written a cubed. So I write 1/4 and square root of, and what I do is that 8 by 27 is fine. So I would like to keep this 3 here, this 3 here, this 3 here. So I write 8 here, and it's like b minus a squared plus c minus b squared plus c minus a squared over 3, and let me write it spread like this one. So it's like same thing, a plus b plus c whole. If you look closely, this you have got like this, means a plus b plus c whole squared. This is same, this is like if you call this whole thing as alpha, suppose call this whole thing as alpha, then this is alpha and alpha, right? Alpha cubed. Why alpha cubed? Because of course I want to apply some kind of AMGM is on my mind, that okay, I may apply like this one. So I wrote like this here. Till here it is fine. Now, so now I am applying again this form, that this is suppose beta, this whole thing is beta. So I will write alpha plus alpha plus alpha plus beta over 3 over 4. This is greater than equal to 4th root of, and this is alpha cubed times beta. This only is there, we have got beta is whole, this only is here, right? So it means that if I want that, I can write that alpha cubed times b, that is here 3 alphas. So this is alpha cubed times b, and this is less than equal to 3 alpha plus beta by 4 to the power 4. Are you getting my point? This is what we are getting, to the power 4. 3 alpha plus beta over 4 to the power 4. This is the tricky part. This is here. So I have just written the new thing, alpha and beta. And what is 3 alpha plus beta? 3 alpha plus beta means you have got b minus a squared plus c minus b squared plus c minus a squared and plus a plus b plus c whole square. That's really nice. If you check that out, you will get, this is b squared, so you will get 2 times, you will get here 2 times a squared, b squared, c squared, and minus 2ab, so you'll get minus ab minus bc minus ca. But this is nothing but a square, b square, c square, and plus 2 times ab plus bc plus ca. So this cross terms cancels out, giving perfectly 3 times a squared plus b squared plus c squared. So that is what we get 3 times this one. So this term has come up. Finally, this term has come up. Are you able to see that this term has come up? Unfortunately, I have to turn the page now, so I have to add one more page. So 1/4 of we have this till here. So stay with me now. 1/4. So just take care of the coefficients. So 1/4 8 times, and this 27 was here. So first we did this 2/3 and alpha. So now I am writing here that this is I have to write this as this inside thing, alpha cubed beta. I have to write less than equal to 3 alpha plus beta plus 4 over 4. That is 3/4 times this one and power 4. So I can write p less than equal to, next page I can write p less than equal to, and this 1/4 I'll copy. So this 1/4 is copied, and the square root of, this is square root of still, and you have got 8. So let's write 8 here, and you have got alpha cubed b. So alpha cubed beta, beta is whole, a plus b whole square, that is 3 alpha plus beta, that is this much. So that is 3/4 and this one and to the power 4. So I'll get 3/4 a square plus b square plus c square and to the power 4. So now look at now is the time to look at the thing that we got here. That this we had to relate it to whole squared, right? So whole squared has come because this is power 4 and this is this one, right? So now Now you have got 4 to the power 4, and so this is p less than equal to 1 by 4, and this is, you have square root of 8 and upon 4 to the power 4. So 4 to the power 4 is now just, you can write something. So 4 to the power 4 I'll write just, and then this is 3 to the power 4 and a squared, b squared, c squared to the 4. Obviously it will give me, that is p less than equal to 1/4, and this is 2 root 2. This is 8 becomes 2 root 2, and 4 to the power 4, so that gives you just 8. So that gives you 8. Just check these works, that 4 squared, this is 4 squared gives you, this gives you 16 in fact, this gives you 16 in fact, and then this is 9, and this is here a squared plus b squared plus c squared whole squared. So you got p less than equal to, that is your 3, and this also will cancel. So you will just check what you are getting. So you should get 9 root 2, and this is, you will get 32, and times a squared plus b squared plus c squared whole squared. So you have proved this one, 9 root 2 over 32. 9 times root 2 over 32, which we can write in different ways also if you write the other thing. So this we are getting p. Now it is not enough. It is not enough to just show that this m is a 10. This m is there. You have to show that this m, the claimed m, 9 root 2 over 32, and this carries a lot of weight. This is attained. This is attained. That's the big deal. You have to show it. Otherwise, it's incomplete. You have to show that this is really attained. This is really attained. But that is easy now, because you check all the cases where equality have applied. So first inequality was here. So this equality holds. This equality holds. This one. This holds. AMGM simple, or x equal to y. This holds when c minus b equals b minus a. That is 2b is a plus c. That is your ABC are in GP, ABC are in AP. So you get 2b is a plus c. So one, you got this, 2b is a plus c. So that is one thing, 2b equals a plus c. Second, you come here, that this is here, that we applied again here. Here you applied on these numbers. So this will hold when a plus b plus c square is equal to this, right? So this will hold. This will hold when alpha equals beta. That is, so I will write on the next page. Condition of equality was 2b equal to a plus c, and also when this big thing, this alpha, that is b minus a squared plus c minus b squared plus c minus a squared over 3, and that equals a plus b plus c whole squared. I can of course put 2b is a plus c. So I can put 2b is a plus c. So you can check that 2b is a plus c. Let's check b equal to a plus c by 2. So I can put it here. So b equal to a plus c by 2. So I can write a plus c by 2 minus a whole squared plus c minus b a plus c by 2 whole squared and plus c minus a whole squared over 3. And this is a plus b plus c. So a plus c and b is a plus c by 2 whole squared. This one. So you are getting this as a minus c by 2 here. Everywhere same thing you are getting. So this is a minus c. So 1/4 and 1. So you are getting 3 by 2. So this is half, 3 by 2 times c minus a whole squared over 3. And you are getting this as 3. So 9/4 a plus c whole squared. If you do it correctly, so this is 3 is gone. So I'm getting 2 times c minus a whole squared is 9 times a plus c whole squared. This will give me the ratio of c and a, right? Because I can just write this one. So let me go to the next page and do it. So you're getting 2 times c minus a squared is 9 times c plus a whole squared. If you write, you can also write at some different thing, but I've taken ABC to be positive, this one. ABC not positive, I've taken this to be this one, that a less than equal to b less than equal to c, this one. I can just choose b equal to 1. So if I choose b equal to 1, then you see 2b equal to a plus c is there. So you got a plus c equals 2. And so I can write 2 times c minus a squared is 9 times 4. And so c minus a squared is 18. And so I can get c minus a is 3 root 2. 3 root 2. And c plus a anyway is 2b. So C plus A is 2, and then you will get one this thing that you can get A as 1 minus 3 root 2 by 2. Just check it, and you will get C equal to 1 plus 3 root 2 by 2 and B equal to 1. It is just required to exhibit just one value, right? There may be infinity of values, and of course there will be, but you just required one. So you are saying that the greatest value, this is B is 1. So you are saying the smallest m. Of course greatest does not make sense because it can be infinity. So you wanted the smallest m. So you are first saying that you are claiming that smallest m, for which this holds for all real numbers ABC, is 9 root 2 over 32. That we got 9 over 32. That is here 9 root 2 over 32, that magical number 9 root 2 over 32. And you also proved that this is you have required this is true. And so if you put this one, you have told that how you will get one triple values. And so I can say that the triple value is 1 minus 3 by root 2. So if I write in the order, then A is 1 minus 3 root 2 by 2, B is 1, and C is 1 plus 3 root 2 by 2. So this is a triple that satisfies this, and we of course get that this P less than equal to m times A squared plus B squared plus C squared whole square for all real A, B and C. Is that clear? For all real A, B and C. This kind of thing should be clear to you. If you know it, then you will understand that, okay, this is what is happening. So let me quickly review this problem. Let me quickly review so that you get a better idea of this. So a quick revision follows that, a quick recap. That is this, that first of all, we factored this. That was essential. Now this factoring business is coming in many exams, like it may come in your IOQM, it may come in your other contests like American contest AMC or AME or other thing. One part will be there. So we factored it. After factoring, just to take care of things, we impose some order so that you can get some negative positive things, so that you can apply AMGM inequality. So I applied that, and then there is somebody asking the question that, okay, so you can just check you can just come to the class and you can understand that what you get there. So now this is A minus B minus C minus A and A plus B plus C. So now you have got this kind of thing. So you have this ordering. The moment you do this ordering, then modulus has come up and you can square, and ordering helps you. And last thing was this one, that this was not so symmetric. So still you try to involve all C minus B, A minus B, B minus A. And after involving these things, then you are writing this 3 times this one, root A squared B squared C squared. And the effect is that if you do this, then 3 alpha plus beta, it comes out to a very nice number. This comes out to be 3 times A squared plus B squared plus C squared. And that is really nice, because after that you will, of course, this, let me write once more, that after this you are quickly getting the answer, because that constant you have been able to relate all these variables to the right hand side that contained A squared plus B squared plus C squared whole squared. So based on that you got this idea. And last was that checking equality cases. Let me remark, it is very, very important, because normally in any contest, say it is of, suppose it is of 10 points, then certainly 2 points or 3 points will be there for showing the equality case. 2 points certainly, and depends on how trivial it is, or how trivial or how much difficult it is to get the equality condition. Based on that they will allot some marks. So but this is essential. Without it, of course, your solution is incomplete, because you have just said that P less than or equal to, right? So we do not know whether equality is attained or not. And so if you want to see so smallest, then you have to make sure that you write that conditions, and that we wrote, because I just went backwards and I just checked all the places where equality will hold. So first was this one, case of inequality, AMGM, and next was this one. There also this RMS aim. So we found that these things must be there, and based on that I'm trying to find A, B and C systematically. So it's a simple equation, but nonetheless it has got its charms. So I found that this happens, and I got A, B and C. So this is one triple of values, 1 minus 3 root. In general, if you have got a ratio of ABCs like this, then also the method will, then also this will hold. and you will get it. Any doubt here? If any doubt is there, you can just let me know, or you can later write in the chat box. So this IMO problem has its own kind of flavor, where with inequality you also have to deal with non-symmetric cases, because they are difficult to find non-symmetric cases, and that's why there are a lot of examiners, because it is hard to guess, right? So it is hard to guess, and I hope that this is the kind of thing that you are doing. Any doubt here? All clear? Today there is no lag. I suppose there is no lag, right? Because last time there was lag, people told. So I think this time it is going smoothly. There is no lag as such. Yes, 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 yes. Whatever your name is, Darren Arola, you can ask your doubt quickly. You can ask your doubt. In any step, if you have doubt, you can quickly ask. Okay, how do you find values of A and C? Okay, okay, Senapai. I found like this. See, the most important part was this one. See, we applied, good question. We applied, see, this is one case of inequality here, right? I'm applying this one, x plus y whole square. This I'm applying right here. This holds when C minus B, B minus A. That you understand, right? We are applying here. Okay, this is one. And other inequality cases, another, so this is one inequality case, this is another. Okay, Dhyan, I'll just try. This is one inequality case. I'll come forward. This is one case where equality holds. And also, note here, especially note here, you are applying this one. This equality holds when alpha equals beta. Alpha equals beta. That's what I'm writing. Alpha equals beta means this one. Alpha, this was your alpha. This your alpha. And this was your beta. So this is a condition 1, and this is condition 1, you say, and this is condition 2. So this step is this one. So you got, if you simplify that, you get here. Now here I am in, this is beta. Now in second I am using this one. Means here I used everywhere. This involves A, B and C. I got rid of B here because I put B equal to A plus C by 2. So I put A plus C by 2, and then this all is coming now like this. So 3A plus C by 2, it is all calculation simple. You got this one, 9A plus C whole squared. Okay, 9AC plus A whole squared. And then last step is that when I wrote this one, then I choose B equal to 1. You can choose anything you like. You choose B equal to 1. You choose B equal to 1. You can choose anything you want, because B is of course to be C plus A, that's all. So because there are 3 equations, 3 unknowns and 2 equations only, no? Because you have got 2b C plus A and this one. So I chose this is 1, B equal to 1, right? If I choose B equal to 1, then of course C plus A is 2, so I got 4, and then C minus A square is 3 root 2 because it's positive, and C plus A is 2, so I get A and C, and I get B also. So I'm able to generate a triple of values A, B and C such that the following thing holds. And then you are saying that yes, this is there. Yes, a course on ISI is in the works. So those who want the course, okay, okay, B is 1. Yes, Senapai, good question. B is 1 is our choice, right? Any B will work, right? Many B will work. Okay. Yes, there are questions asked of Pallab. There are questions asked of INMO level there. Very much INMO level. At least INMO level may be a little tough, but RMO level certainly. So ISI is a good exam and questions are really great. So I mean that there will be a course launched in due course. You get in touch, you keep seeing my page, and you get in touch with the people who are in my batch. They will let you know. So thanks for listening. That's all for you today. So hope you enjoyed the session. Please write in the comment box, and let's meet next time, a second time. Okay everyone, hope it was good.